Hello all, let's start section 3.2. I'll do really a quick lecture on 3.2 because I'll just here introduce the two theorems for you. I will not focus too much on 3.2. Our main focus will be on 3.3. I'll just introduce these two famous theorems for you. We may use these theorems in future chapters, but right now, just a quick overview on these two theorems. 3.2 is about the mean value theorem, but before I focus on the mean value theorem, let me introduce to you another theorem, which we call it Rolle's theorem. Rolle's theorem. Actually, what is Rolle theorem says? In an easy language, some professors even they're saying if you have an x-intercept, but let me tell you something. If you have a graph of a function, for example, like this is a function f. This is the graph of function f. And you have 2 points here. One of them is A, one of them is B, correct? The Rolle's theorem says, number one, if your function is continuous on a closed interval AB. This is a closed interval AB, and if your function is continuous, it means there is no gap there and there is no discontinuity there. There is no hole there. This function is continuous, correct? And also, if this function is differentiable in an open interval AB, you can see that if a function is continuous, you already learned that you can differentiate your function in an open interval AB, correct? And also the important point, f of A equals f of B. That's why some professors, they bring this example and that, oh, if your function intersect the x-axis, correct? It doesn't matter if you intersect the x-axis as long as f of A is equal f of B. Let me draw another graph for you. It shouldn't be always intersecting the x-axis. For example, look at this function. This is A, this is B. F of A, which is here, this is your f of A, also equals to the f of B. You see, they're in the same line. As long as f of A is equal f of B, then what the Rolle's theorem says definitely there is a point on a graph that the derivative becomes zero. Here is that point, you see? Here is the point. A horizontal line. There is a horizontal line or a horizontal tangent line that, because we know the slope of the horizontal line is zero, then definitely your curve have a horizontal line, or there is a point that f prime C, if I name this point C, correct? F prime C is equal what? Zero. We call this theorem the Rolle's theorem. And it's true. It's working with any curve. If the two endpoints are equal to each other, definitely there is another point on the curve, or maybe points even on the curve, that your first derivative becomes zero there. Correct? Now, comparing this curve with this one, I'll do a jump here from one theorem to another one. Let me draw another curve here for you. Let's say, for example, I'll draw this curve. and I'll draw my secant line maybe here. This is my secant line, correct? Of course, this point, I'll name it A. This point, I'll name it B. Of course, the coordinates of this point will be A and F of A. And the coordinates of this point will be B and F of B, right? Now, you see, if I draw different tangent lines on my curve, for example, I'll draw one here, I'll draw another one here, correct? And finally, there is a tangent line here that the slope is equal to the slope of the secant line. It means these two lines are parallel to each other. Again, if I name this point C, correct? First of all, what is the slope of the secant line? The slope of secant line will be f of B minus f of A over B minus A. This slope of the secant line will be the slope of this tangent line, which is parallel to this line. And what is the slope of the tangent line here? Of course, that's f prime C, right? We call this equation the main value theorem. Basically, what we do some proof on these theorems. For example, they will give you a problem. At what point the tangent line is parallel to the secant line, right? They give you the value of A, they give you the value of B, and you're looking for the value of C. Those kind of problems that we will not do it in this class. Only I will introduce this. My goal was to introduce these two theorem, and you see they're really, really close to each other. The idea is the same in both theorem. The only difference is here your f prime C is equal 0. Immediately you make it equal 0 because the line is a horizontal line. But in this curve, you have to make the first derivative equal to the slope of the secant line. This one, we call it the main value theorem, and the first one, we call it the role theorem. I told you that we are not using it now. In future, maybe we definitely in calculus we use it, but we will use it in future. Just remember, just understand what does it mean, because the way even I had planned to do not do a lecture on this section, but when I saw the book is explaining this theorem really, really in a difficult way. That's why I try to say, okay, I'll do a quick lecture, because if they read just the book, they will not understand what it's talking about. That's why I did this lecture for you. These are your two main theorems, the role theorem and the mean value theorem, and hopefully we will use it in future. I will not do any example here. I will stop the lecture here, and we will have a really, really long lecture on section 3.3. That's our focus, and see you next time in section 3.4.